Today on NerdOut, guaranteed transaction delivery. Welcome back to NerdOut, the show where we take a look at Cardano and we break it down, but we don't dumb it down. Today we're talking about guaranteed transaction delivery, what it is, why we need it on Cardano, and we'll take a little look at Firehose to see how we implement it there. So you may notice I've renamed Firehose to Phyrhose, and that's because it's really hard to get a domain name with a regular word like Firehose, so we went with a phonetic spelling for that. So in the future, if you see Firehose with the PH, that's what I'm talking about, but it's the same system I've built. So first of all, guaranteed transaction delivery implies that drop transactions happen. So how do these happen? So in the scenario where a block is received at a node, there are transactions in it, and those get then removed from the mempool. Once they arrive in a block, the mempool gets cleaned out. Then let's say a second block arrives that rolls back that first block, either a slot battle or some type of a fork. Anyway, that block that was on chain that had its transactions removed from the mempool is now replaced by another block. And maybe this new block does not have the exact same transactions in it as the first block. So the difference in those transactions are just lost at this point. And this also has to happen where all the nodes on the network have received these two blocks in the same order. So for example, if the blocks had come in a different order on one node, so on my node, let's say the rollback happened. If they arrive in the other order on the other node, maybe the rollback would not happen. And so then the mempool is still correct and doesn't have any drop transactions. And then if that other node is well connected, it can kind of reinflate the mempool of all the other nodes after that rollback fork event happens. And that's a pretty common occurrence on a blockchain. And we expect that under Ouroboros consensus, because the pools don't know the slot leaders of any other pool, and sometimes they will mint in the same slot. As you can see, it's kind of a rare occurrence, and it's only likely to happen during heavy network congestion. So during an NFT drop, or once we have DeFi, you may see this occur more frequently. So in Firehose, we do transaction chaining. So if you're chaining one transaction to the output of the other, it's very important to never have a lost transaction or a drop transaction. So if one of these transactions is ever lost, it's going to break that chain, and then Firehose becomes not very good. It becomes a dribble hose. So how can we resolve this scenario? I was first made aware of it by talking to, I'm going to butcher his name, Carl Knutson is how I'm going to say it, from IOHK. He is the Haskell engineer for networking, and he helped explain it to me and propose some possible solutions as well. So thanks to Carl. So step one, how do we resolve it, is we first cache any transactions that we submit through Firehose that have made it into the mempool. And we cache those in memory until we see it land on the chain. And so that's what I'm doing here as we submit the transaction, and we're storing it in a cache based on its transaction ID and then the raw CBOR hex that we submitted to the mempool. And then whenever we see a transaction in a block, we save that off so we can mark it as belonging to that particular block. So we're just kind of saving it off here. So when the new block arrives, we're saving it off in this CBOR transactions that we've seen in a given block. And then step three, once we're looking at that newly arrived block, we check to see if we already have that same block number in our cache. If we already have that block in our cache, that means it's the second time we've seen that same block number, which means we have just jumped onto a new fork and our old block is no longer valid. So a rollback event has occurred here. And so that's what we're doing here. We're checking the block rollback cache. If that block number is present, then we handle the block rollback scenario. And you'll see on the next slide what that function does. And then what we do, whether we've handled it or not, we store this latest block that we just received in our block rollback cache for later, in case, we get 2 rollbacks in a row, or if this first block of code here is skipped over, we're just saving that block just in case in the future it lands on a fork. And then we also look in case there's more than 2 blocks in the given fork, like if we jump back 2 or 3 blocks in the chain, we just loop on this to see if we rolled back more than a few blocks, and then we also handle those block rollbacks, and then of course invalidate those future block numbers. So finally, in step 4, this is where I said we'd handle the block rollback, and this is where we resubmit any transactions that truly got dropped. So what we're doing here is we're looking in our rolled back block, and we check the latest block and compare the transaction IDs inside of it. And so any transaction IDs that were in our rolled back block but not in the new block we received, those are ones that we need to resubmit. And so that's what this loop here does. So we're filtering first. And most of the time when there's no load, you're going to see this no transactions found to resubmit, because the blocks will have identical contents. But in the scenario where they don't have identical contents, we'll go ahead and resubmit those transactions to the node, and sometimes they will be accepted. Other times it may exist already. So like in the scenario I mentioned earlier, where maybe our mempool got reinflated from some other node on the chain before we could do the reinflation ourselves. Like if another node saw the blocks in the correct order and we saw them in the wrong order, so maybe the resubmission will succeed, maybe it'll fail, it doesn't matter. But at this point, we have done all we can. We've gotten as close as we can get to guaranteed delivery through Firehose at this point. And that is how we do guaranteed delivery of transactions that are coming through Firehose. And with that, nerd out.